All right, today's lesson, we're going to be proving that a segment that joins midpoints of two sides of a triangle is parallel to the third side. Let's start with this triangle here. Given a triangle ABC, and we have a segment that is joined at its midpoint. E is the midpoint of AB, and D is the midpoint of AC. We want to show that line ED is parallel to BC. Well, let's just start with the definition of midpoint. If E is the midpoint of BA, that means BE is congruent to EA. And if D is the midpoint of AC, that means AD is congruent to DC. All right, we already established that these sides are congruent based on the definition of midpoint. Look at angle A. Angle A is part of angle ABC and angle AED. So by the reflexive property, angle A is the same measure for both triangles. What we want to show is, I'm going to break it down like this, that these two triangles are the same. And what we establish is, let's call this AED. We know that that angle is the same. And let's compare it to the large triangle. You have A, B, C. If you look at that pattern carefully, you see side, angle, side. That means that these two triangles are congruent, which means corresponding angles are congruent. Angle 1 corresponds to angle 4. Therefore, by the definition of parallel lines, if you have corresponding angles that are equal to each other, that means that two lines are parallel. So that means that this line, ED, is parallel to BC. Simply because the corresponding angles, one is congruent to angle 4. So we have proven that ED, that's the segment that connects to the midpoints of the larger triangle, is parallel to the third side. And that's the conclusion of this lesson.